Chapter 11, Section 7 is about rational equations, and so we're going to see some of these rational expressions that we saw so far throughout this chapter, but we're going to also see an equal sign now, so we're actually going to be solving for the value of the variable that we have in our problem. In order to do these types of problems, you're going to need to make sure that you have a least common denominator, so you have that common bottom for your fractions. Eventually what's going to happen is that we're going to get our denominators to cancel out, and I'll show you kind of a quick way to have that happen. And then we're going to solve for our remaining variable. Remember that we can't divide by 0, so if we see something like that happening in any of our problems, we'll either have to go back and reevaluate what we did, or we won't be able to actually solve that one. So for example, if I have 7 over r plus 2, and that's equal to 6 over r minus 5, I'm going to try to solve for my letter r here. Now I need to find a common denominator first. I need for both of my denominators to have each of these pieces here. So if you remember what we were doing with section 6 when we were adding and subtracting our rational expressions, we had to have common denominators. So what I'm going to do is take this first fraction times that quantity I'm missing, which is r minus 5. And the second fraction, I'm going to take that times the r plus 2. So when I do this, what I want you guys to understand is that I would have these common denominators here, and what would eventually happen is I would want to get rid of the fractions altogether, and so I would multiply both of my fractions by what's in the denominator. Think back to if you had something that looked like this, 5 over x equaled 2. If you wanted to get rid of x from the denominator, you would multiply both sides by that x to get those to cancel, and you'd be left with an equation that looks like this. Okay, now we would do the same thing for this type of problem, but we would have to multiply by that common denominator, which is r plus 2 and r minus 5. What I'm going to tell you guys that you can do is kind of skip over showing me all of that work and just understand that what we're doing is we're trying to multiply by that common denominator in order to get the pieces to completely cancel. So what I'm going to do at this point is I'm going to assume that these denominators basically cancel off, and I'm just going to work with the numerator parts. So on the top, I'm going to take 7 times the r minus 5, and I'm going to do 6 times r plus 2. So I have 7 times that r minus 5, and we're setting it equal to that 6 times r plus 2. And like I drew those arrows in, we're going to have to distribute. So now it says 7r minus 35 equals 6r plus 12. And like I said, I'm basically skipping over the whole portion of me canceling out those denominators, because it would just, I could show you, but it's going to have a lot of these extra parentheses. And so I'm just letting you know right now that eventually what happens is you're able to cancel them off, and you're just going to be left with the pieces on the top. Now to solve for r, you're basically down to a regular equation that you guys have been solving pretty much all year long. So what I'm going to do here is add 35 over to that 12. So we have 7r equals 6r plus 47. And then I'm going to subtract my 6r from the 7r, which would just be r equals 47, and there's your answer, because you're solving for that variable. So I want you guys to try this practice problem. So take a minute here, pause the video, and go ahead and try to do this one, and then come back and watch for the solution. So your common denominator would have been the x plus 3, x minus 4. So you need to take the first fraction times x minus 4. And the other side, you need to take that one times the x plus 3. Again, my denominators would eventually cancel, so I'm not going to worry about them right now. So on the top, you're going to want to distribute the 5 and your 4. So it's going to say 5x minus 20 equals 4x plus 12. And then I would have solved for x, so I would have added 20 over to the 12. So now I have 5x equals 4x plus 32. Then I would subtract the 4x. And I would get x equals 32. All right, let's take a look at another example that's a little more complicated. So this time we have 3 fractions. We're trying to add these fractions over here on the left, and then we have it set equal to this other fraction here on the right side. The first thing I would do is take a look at the bottom of that last fraction that says x squared minus 9. Remember our factoring that we've been doing periodically throughout this chapter with those rational expressions. This can factor to x minus 3 and x plus 3 because it's the difference of 2 squares. So your common denominator would be for each fraction to have both of those parts to it. Now the first fraction here has the x minus 3. The second one has the x plus 3. So we're again going to have to multiply by the appropriate pieces. So for that first one, you're going to want to take x times the x plus 3. The second fraction, you're going to take it times x minus 3. You won't have to do anything to the last fraction because it already has both parts. Now again, we're going to kind of skip over the part where I show you all the work that goes behind how those denominators cancel, and we're just going to imagine that all of these have gone away now, and we're just dealing with the top portions. So again, make sure that you're being really careful here and you're distributing where necessary. So you're going to have x squared plus 3x plus, that second fraction now is going to have x squared minus 3x, and then it's equal to a 2. So now what I'm going to do is try to see if there's anything that I can combine. Well, I see x squared and an x squared, so I'm going to be able to put those together. That would be 2x squared. Now if you look here, we've got a 3x, positive 3x, and a negative 3x. Those are opposites, so they're actually going to cancel each other off and become a 0. And so what I'm left with is that equals 2. Now to solve this one, I want to get my x by itself. So right now it says 2 times that x squared. So I'm going to divide both sides by 2. So we have x squared equals 1, because 2 divided by 2 would be 1. And remember, to get rid of something that's squared, you square root both sides. And when you square root something, remember there's always that positive and that negative answer. So plus minus 1 would be our answers for x. We needed 2 of them because we had that x squared. So the x squared, the little 2, tells you that you should have 2 answers that you're able to find. Now you will want to be careful when you're looking at some of these that we don't want to have our denominators equal 0. So when I got my answer here for x, and on those problems on up above here, when we found x to be 32 and x to be 47, if I go back to my original denominators, so anything that we started with in our first problem here, if I get a 0 when I plug in that value I got for x, I would have to throw it out because it wouldn't be any good. So if I put in positive 1 or negative 1 anywhere up here for my x's, I would not get any zeros in the denominators, so I should be able to keep both of those answers. If I were to get a 0 though, I would need to just throw out that number because it wouldn't be any good. So again, I've got a practice problem here for you to go ahead and try. And then when you're ready to see what the answer should have been, you can keep watching. So first thing you should try to do is factor this. So you need 2 numbers that multiply to 2 and add to 3. So that would be x plus 2 and x plus 1. So you need both of your fractions to have those parts. You don't have to do anything to that first fraction. So I'm going to go ahead and just take this x minus 1 and drop it down. The second fraction, though, has x plus 2, so it's missing the x plus 1. So you're going to have to take that top times x plus 1. So that would become 2x squared plus 2x when you distribute. The last fraction is missing the x plus 2 quantity. So you're going to want to multiply that to the top. Now, on the top here, you're going to have to distribute several times, or you're going to want to use that FOIL shortcut that we've talked about. So you're going to take x times x, which would be x squared. Then you'd have x and 2, which would be 2x. Negative 1 times x would be a negative 1x, or negative x. And negative 1 times 2 would be negative 2. So here's our equation. So now I'm going to start combining like terms if I can. So let's just kind of focus on the left side and the right side for right now. So I have 2x squared, x and 2x, which would be 3x. And then I have minus 1 equals, over here I have x squared plus x minus 2 when I combine those terms. Now let's get everything on one side of the equal sign here. So I'm going to actually take all of these terms and push them over to the left-hand side. So I'm going to subtract x squared, subtract the x, add the 2. So this would have come out to be x squared plus 2x plus 1 equals 0. If we try to factor this, two numbers that multiply to 1 and add to a 2 would be 1 and 1, so x plus 1, x plus 1. Again, if we're setting those equal to 0, since it's the same thing, you only needed to set it equal to 0 once. You did not need to do it 2 times. You would have gotten x equals negative 1. But I want you guys to take a look at this denominator that I'm highlighting in green. What would happen if I put a negative 1 there? Hopefully you're realizing that if you put a negative 1 in for x, you're going to have negative 1 plus 1, which is a 0. And we can't have 0 show up in the denominator. So this is actually not a good solution, and we're going to have to say that there's no solution for this problem. If you remember from the last section, we talked a little bit about that equation d equals RT. You know, distance is equal to your rate times your time. And last section, we spent a lot of time with this equation instead, where time was equal to the distance divided by the rate. Now, we could also rewrite this equation for rate if we wanted to. So rate would be the distance divided by the time. So all three of these equations can be used for different scenarios depending on what type of information that they're giving you. Are they giving you the rate and the time, or are they giving you the distance and the rate, or the distance and the time? So for example here, we have that a cyclist travels 8 kilometers in the same time that a walker travels 3 kilometers. The speed of the cyclist is 8 kilometers more than the speed of the walker. Find the speed of the cyclist and speed of the walker. So we're going 8 kilometers total for the distance here. So that's going to be our d that we're going to put on top. And so for our biker here, we've got that they're doing 8 kilometers more than the speed of the person who's walking. Now, I don't know how fast the person who's walking is going, so we can use W for that. But we do know that they're going 8 kilometers faster. So if they're going 2 kilometers, then the biker's going 10 total. Now, for the walker, she or he is going 3 kilometers. And we, again, don't know how fast that they're going. So you'd still need to find your common denominator, which would be to have both of these pieces here. So this first fraction is missing just that plain W. So I'm going to take the 8 times the W. And the second fraction is missing that W plus 8. This should be an equal sign because they are doing the same time here. So what I'm going to do now is my denominators are going to cancel. I've got 8W equals, distribute the 3. So it says 3W plus 24. I'm going to subtract 3W. So 5W equals 24, and then divide by 5. And we get 4.8 for W. So, to conclude what's going on here, our walker is going 4.8 kilometers per hour. And our person on the bicycle, the cyclist, they're going 8 more. So 4.8 plus 8 would be 12.8 kilometers per hour. So I want you guys to take that same idea and apply it to this practice problem here and try this one on your own. So Sandra is rowing a canoe at Pony Creek. Her rate in still water is 6 meters per hour. It takes Sandra 3 hours to complete a 10-mile round trip. Determine the rate of the current. So the 10-mile round trip would be the total distance. And we're going around. So we're going to kind of split this into 2 parts. So 2 parts of her trip. So 10 divided by 2 would be 5. Now, it says that in still water, her rate is 6 miles per hour. And we don't know what the current would be. So if you think about how a river or like a creek works, there's a current going in one direction. So as you travel in one direction, you're going to go with the current. And as you go in the other direction, you're going to go opposite of the current. So we're going to do 6 for her speed, plus whatever the current is for her 1 half of the trip, and then 6 minus her current for the return trip. Now it takes her a total of 3 hours to do this here. So 3 is not a fraction. Think of that right now as like over 1 if you need to. Your common denominator is going to be the 6 plus c and the 6 minus c. So we need to take this first fraction times 6 minus c. The second one needs to be times 6 plus c. And the 3, you're actually going to have to multiply to both pieces. Again, my denominators are basically going to cancel out here, so I'm not going to worry about anything on the bottom. On the top, again, make sure that you distribute where you can. Over here, what you're going to want to do is multiply or like FOIL these, and then take that 3 into account a little bit later. So here's what it says. 30 minus 5c plus 30 plus 5c, so that's the left-hand side, equals, I'm going to have this 3 sitting out front, and I'm going to FOIL these, or I'm going to distribute. So 6 times 6 is 36, and then I'm going to have a plus 6c minus 6c, and then minus c squared. Now let's combine some of our like terms here. So on the left-hand side, 30 plus 30 would be 60. That takes care of those. We have a negative 5c and a positive 5c. Those are actually going to cancel each other out because they're opposites. Over here, we have that 3. And inside, the 6c minus 6c is going to go away. So we have 36 minus c squared. Now I am going to have to distribute this 3. So we have 108 minus 3c squared. Subtract 108. Whoops. Cross those off. So we'd have negative 48 equals negative 3c squared. Divide by negative 3. You're going to have 16 equals c squared. And you're going to square root that. So the current has 2 options. It can either be positive or negative 4. We're talking about speed, okay, and how fast something is traveling. It's not going to have a negative speed, so we're going to take the positive option here. So the current is going 4 miles per hour. For our last couple problems here, we're talking about people working together and kind of how much they can do or how long a job takes them individually, and then we're going to try to figure out how long would it take them to do the same job together. Or they might tell you how long it takes them to do something together, and you want to figure out how long it would take someone to do it by themselves. So it takes Joe 3 hours to stock pop, and it takes Sue and Joe together 2.5 hours to stock pop. How fast does Sue stock the pop by herself? So for Joe to do one job of stocking pop, it takes him 3 hours. So I'm going to write that as 1/3. For Sue, we don't know how long it takes her to do. So I'm going to put 1/t for time. And you can use whatever letter you want there. Now together, for them to do one job, it takes 2.5 hours. Okay, so for your least common denominator, that would be if it has all three of these pieces here. So 3 times t times 2.5, which would be 7.5 t. So what we're going to do is make sure that all of these have 7.5 t. Really what you have to do is multiply by whatever is missing from your fraction. So like this first one has a 3, it's missing the t and the 2.5. So you're going to take the top times 2.5 t. For the middle fraction, it's missing the 3 and the 2.5, which would be 7.5. And then the last one, you're going to take that times 3t. Again, your denominators are basically going to cancel off. So you're going to have 2.5t plus 7.5 equals 3t. I'm going to subtract 2.5t. So we'd have 7.5 equals 0.5t. Then I'm going to divide by 0.5. So t is going to come out to be 15. So it takes Sue 15 hours to do that one job by herself. It's a pretty long time. So take this same idea here and apply it to this practice problem. Try this on your own and then keep watching to see what it should have been. So we have these two separate churches that are trying to build a house for the community. For the Lutheran church, it takes 24 days to do one job. Together, they can do it in 18 days, and we want to figure out how long it would take the Catholics. So we don't know how long it would take them, so I'm going to put 1/d and set that equal to that 1/18 for the together total. Okay, your LCD here would be if you multiply all those quantities. So for that first one, it's missing the 18 and the d. For the middle one, it's missing the 24 and the 18. And for the last one, it's missing the 24d. Again, your denominators are not important right now. So we have 18d plus 432, when you multiply those numbers together, equals 24d. I'm going to subtract 18d. So we have 432 equals 6d. Divide by 6. And we get 72. So it would take them 72 days to do the job by themselves.